In this lesson, I'll show you how to compute the polar moment of inertia using the shell method. The formula that we'll be using is right here, and the variables are defined below. The question reads, the first quadrant area under the curve y squared is equal to 8x from x is equal to 0 to 2 is rotated about the x-axis. Use the shell method to find the polar moment of inertia of the paraboloid generated. Let's start this question by discussing the formula. We have inertia is equal to 2 times pi times m, where m represents the mass per unit volume. It's unknown in this question, so we'll just leave it as m throughout the calculation, times the integral of r to the power of 3, where r represents the shell radius, times h, which represents the height of the shell, dr. Because our shells are oriented this way, this means that the radius of these shells is equal to y. With that being said, our function will be in terms of dy. The height of these shells, on the other hand, will be between 2 and a variable distance x, which we denote as 2 minus x. In fact, later on we'll be replacing x with the function. With that being said, let's go ahead and fill in our formula. We have I is equal to 2 times pi times m times the integral between 0 and 4, and I'll write down dy in place of where we had dr. The radius is y, because as we take shells all throughout this curve, it will have a variable distance from its center, and that we can write down as y times h, which was 2 minus x. Of course, x can be our function where we solve for x. So that's y to the power of 2 over 8 will be in place of this x. And now we can start to integrate. Y to the power of 3, 2 minus y to the power of 2 over 8 dy. Now all we have to do is expand and then find the antiderivative of the two terms. 0 and 4, we have 2y to the power of 3 minus y to the power of 5 over 8. Now instead of doing this manually, we all know how to do this manually, especially if you've gone this far in Calculus 2. So I'll just use my calculator to find out what this is equal to. And I can do that by clicking this, typing 2, and then our variable, to the power of 3, minus, again our variable, to the power of 5, over 8. Make sure that this is in brackets just to prevent any sort of errors from happening. We put in our bounds 0 and 4. This gives us 128 over 3, and we'll multiply that by 2 and by pi. Multiplying that by 2 and then multiplying it by pi gives us the following answer: 268 m. Because remember that m was never given to us. That is the moment of inertia using the shell method. If you watch the next video, I'll show you how to compute the exact same thing but using the disk method.